Hi, everyone. Thank you for joining this talk today. I'm very excited to be your host for the next hour or so. And we're going to be focusing around DevOps Dilemma, navigating stateful apps the Kubernetes way. So what we're going to be talking about today is DevOps gone wrong and how ultimately we can put guardrail in place, but more importantly, also try to answer the question, should we put any guardrail in place when it comes to DevOps? Because to some extent, one could argue that by putting guardrails in DevOps, then potentially it's hindering innovation, putting more constraints on developers, which ultimately may be bad for the business. So we're going to take a look at this, especially in the context of Kubernetes and stateful applications, because as you know, stateful applications are more critical application that you can run in Kubernetes. So when it comes to them, what can we do to limit the blast radius of things that can go wrong with DevOps? So, but before going into this, a bit of introduction myself. So I'm Nick. I'm a principal developer advocate with OnThat. In terms of my backgrounds, I've been working with Linux, Unix for the past 17 years. Been with Kubernetes almost since the beginning for the past around 6 years. I've also spent around 6 years at Cisco and probably 4 years on Kubernetes, where I was more on the networking side, working on CNI plugin, SDN solution, these kind of things. I'm a DevOps and automation junkie. I guess this is because I'm kind of lazy. But yeah, I really enjoy simplifying people's lives by building cool tech, cool products, and also teaching people, learning from people, and sharing all of that in communities. So at OnThat, we're part of the DOKC, so Data on Kubernetes community. If you want to check them out, so we also do some activities in this community. And in terms of my personal life, big fan of animes, Marvel comics, and groove metal as well. Okay, so let's get going. We're going to be talking first about the foundation of Kubernetes. So I didn't mention, but I'm going to try to keep this talk rather short so we can go into a demo of policy as code or this kind of cool stuff. If you have questions, there is on the right a section where you can ask those questions. You can enter them as we go, or you can also ask all the questions at the end. I will check them out when they pop up. So let's talk about Kubernetes first, the foundation of Kubernetes, of course. Kubernetes is well known to be this cloud-native platform where you can do a lot of automation, very strong API, very popular API, but the problem is that when you want to start building an application inside Kubernetes, well, there's no manual on how to do it. Right? There's so many ways of doing things in Kubernetes. It can go very messy, very quickly. And the risks that are tied to DevOps in the context of Kubernetes are exactly the same risks you have with automation at scale. It's like if automation is great, but when you're automating something that is wrong, then the blast radius is gigantic. The same applies with Kubernetes with a couple of other concerns. I would say first, the sprawl of tools. There are so many tools within the Kubernetes ecosystem. I don't know when was the last time you've checked the CNCF landscape, but it's just getting bigger and bigger. I mean, which is, don't get me wrong, this is a good thing, but it also means that you need to prepare more, you need to evaluate tools, you need to be fast to evaluate them, to test them, compare them, so that you can adopt the right tool for the right job, which is probably one of the most difficult things to do in Kubernetes. Ultimately, like a sprawl of tools leads to extra complexity, not as if Kubernetes was not complex enough. What I've noticed, I've been a Kubernetes user for many years now. Every time you want to do something in Kubernetes, you want to say, okay, I want to simplify my life. I'm going to use this. And guess what? At the end, you're like, okay, maybe now it's to troubleshoot. it's even more complex now. Maybe on the, the consumption model, the way you do things every day may be easier, but you may lose some, correlation capabilities or visibility. So you have to pay attention to those things if you want to run at scale in production with Kubernetes. Security is also a big concern when you start DevOps, when you start DevOps with Kubernetes, because as always, security comes last. So we even started to talk about DevSecOps at some point a couple of years ago, because security needs to be embedded in DevOps day one. It should not be something you're like, oh, I'm going to ask my CISO or the security team at some point. You invite them. No, it doesn't work this way. You have to work with these teams from day one so that you can have the right compliance rules in place, and you can integrate that into your DevOps cycle, which is what we're going to see today, how to do this. Another issue can be resource control and cost, of course, because you have now a lot of different tools. Those tools typically, and this is another topic we're going to touch on today, those tools are using their own API extension in Kubernetes, so relying on things like the Operator framework, whereby you can automate some things inside Kubernetes with a custom controller. We're going to go deeper into that. But obviously, with all this extension, it can lead to a sprawl of Kubernetes objects, and objects that are not standardized. Those are not native Kubernetes objects. Those are custom objects. So how do you control them? How do you put compliance on those? And costs. More resources you add in Kubernetes, the more nodes you need. Potentially stateful app, you also need storage, which does have a cost if you're running in EKS or any other cloud. So yeah, it does have a lot of impact when you start, when things tend to go not necessarily bad, but just scale with DevOps. Those things need to be taken into consideration. And finally, when you've got too much going on in your DevOps environment, when knowledge, some people are focused on one part of the pipelines, on the processes, other people on other areas, and then developers that have not been trained on the particular tool set, then it's a big mess, which ultimately is counterproductive, because the goal of DevOps is obviously to accelerate the release of the software with shorter cycles in the development, different development phases. But actually, if this is going wrong, it's going to slow you down, right? So instead of having a strong, the best possible product you can have, actually you're going to have lower software quality. You're not going to be able to match your deadlines, and you're going to be in a constantly trying to rework on your DevOps processes if you start to do wrong from the beginning. And I've seen this many times. So, but now that we have been talking about the problem, what are the options to save us from this kind of sin? Right? So I would say the first one is not really technical, at the beginning at least, but people come first, as always, right? So it's really about transforming the teams, the interaction between teams, before saying, okay, I'm going to go full Kubernetes and I'm going to do DevOps within Kubernetes. When I say DevOps within Kubernetes, is using Kubernetes native tool, which we're going to mention a bit later. So everything basically running inside Kubernetes, your application, your code, your test, but also your automation running inside Kubernetes, your DevOps pipeline running inside Kubernetes. Another tip is really to use short iteration cycle for with the goal of incremental changes. So don't try to reinvent the whole thing from the bottom up. If you already have some component in place, focus on those, what we can say, quick wins or incremental changes that you can bring to a solution, to just to a process, to a pipeline, to how you do things in terms of the software that you deliver or the software that you test. Testing is a great area to start with. Maybe you don't have automated test. This is something you can enabled with Kubernetes, and this is low risk. So maybe start with this kind of initiatives, exactly by focusing on what brings value to the business. Maybe a full end-to-end GitOps pipeline with everything automated doesn't bring so much value. Maybe if you can accelerate like 10% of this particular phase, you can have a better impact and direct impact on the business as well, right? So focus on these little things rather than trying to build anything, from ground zero, right? But also, when you reach this level where you're like, okay, now I'm going to go serious about Kubernetes and DevOps, what should I consider so that it's enterprise ready for more critical application, like stateful application? I mean, of course, this is valid for stateless application, but it's even more important for stateful application because it does impact directly, more people, more business and customers. So the first one we're going to mention, I'm going to describe them later in details, but those two ones to begin with are GitOps and policy as code. So GitOps, I'm just introducing it there, is just a CI/CD pipeline that has specific properties that will help you deploy, build, update things inside Kubernetes. And policy as code is really a way for you to specify constraints around the Kubernetes object you want to deploy in your cluster ideally before they got deployed into Kubernetes. Of course, you can have reports when you are running application in the cluster, but ideally you don't want to put an application or a component in production if it hasn't been checked against your in-house best practices or compliance rules or just overall guidelines. And this is also true for developers during the development cycle. The development phase, the phase one of the code, right? We're going to see like a good example of this during the demo. And another thing that leads to, actually I already mentioned it, but one of the things that leads to a sprawl of resources in Kubernetes are those operators. But I want to give you a bit more details on how it works and what operators are really key, especially again to run stateful application. So the concept of an operator is like a human operator. Actually, you want the operator to do things for you, to facilitate your actions, right? So it's the same principle in Kubernetes. So as you know, Kubernetes is a distributed system, essentially asynchronous, which relies on a declarative model where you specify the intent. So the intent is the single source of truth. What that means is that Kubernetes, as I said, is asynchronous, and every controller has its own view of the system, and ultimately it will converge to the point where what is running in the cluster is conformant with your declarative model, but it's not guaranteed at time t. It can take time. So the view of the cluster is constantly changing because Kubernetes is constantly monitoring itself and the different YAML manifest so that it can reconcile states with the desire, right? And the custom resource is just an operator has two components: a custom controller a software bit, as well as it's code, as well as a custom resource definition, which is a schema, right? So a custom controller is working as a traditional Kubernetes controller. So you have controller for deployment, replica set, all of that. So essentially you're making use of the Kubernetes platform as an engine to track your own resources that you define through a customized schema. So the customized schema is called CRD, custom resource definition, and the logic is implemented into a custom controller. So that custom controller, typically what it does, as you deploy manifests that are conformant with the custom resource definition schema, is going to create what we call a custom resource inside the Kubernetes API. Your custom controller is continuously watching for those custom resources that are living into the cluster. And the custom controller is going to take action and perform a specific action depending on what you have into this custom resource. So why it's important for stateful application, we can take the example of a database. So you have a lot of the operators to install database inside Kubernetes, like MongoDB, you have MySQL, PostgreSQL, you have Kafka operators. So what all those operators do, they not only allow you to install and control the configuration of those components. So through a custom resource, and we're going to see in the demo, you can say, I want that configuration in the database. You need to create this many replicas, like database replicas. You need to create this user. This user needs to have permissions on this database, etc., etc. So you can essentially control configuration elements from your external application. Like, it's not elements that live by default in Kubernetes, but they are now represented into Kubernetes. So the custom controller allows you not only to install and define those parameters as custom resource, but also to operate them. So for example, if you scale the number of stateful sets and pod replicas inside Kubernetes, so the pod construct, then automatically the database will be scaled as well, right? So that means as you scale the pod, as you scale the workloads, you can also scale the application. And it's not trivial, because you need to add a new database cluster member. You need to make sure that things are in sync, etc., etc. So those operators, they do that for you, so you don't have to operate this and install all those components manually. So obviously, now that you understand that it makes your life easier, people tend to use and abuse of custom resources, which ultimately lead to us control them. And how to control them, this is the question, right? And another thing that you can do with custom controller, and this is a trend I've seen in the industry, if you look at things like Crossplane, and probably others are also providing this, you can use custom resources to represent resources that live outside of Kubernetes. So for example, you can represent your EC2 instances as an object in Kubernetes, so that when you create a manifest like an AWS, sorry, excuse me, you can create your custom resource definition and call it EC2 instance, and define the schema you want to be able to control. So for example, you can say instance type, memory, CPU, these kind of things, and put this into your custom in your schema, right? And now what you can do once you have installed this schema into Kubernetes, so you have to build your custom controller that is going to be responsible to manage the CRUD operations, so the create, read, update, delete operations, so the logic, the code on how to do this, talking to AWS. But then what it means is people can now use your custom resource to create their own EC2 object. So as they do, they just create a YAML file, EC2 instance type, this memory, this CPU, kubectl apply -f, this YAML, and then the custom controller will be responsible to manage the life cycle of what is deployed into AWS. So essentially, it allows you to make Kubernetes the automation engine for not only what you deploy into Kubernetes, but also what you deploy in other parts of your infrastructure. And this is very powerful. Okay, so a couple of benefits of the operator. We already mentioned them, at least some of them. Simplify the deployment, scale out or scale up, scale down or scale in of all your applications that are managed by an operator. So not only scaling the Kubernetes construct, but also scaling the application and performing all the relevant actions on top of that. So also in terms of data operations, things like database scaling, backup. I didn't mention it, but it can automate backup, upgrade of your databases. All of that can be managed by the operator rather than manually. So just by putting your stateful application in Kubernetes, you can already take advantage of some of the the platform benefits. And And one important thing is that you can enforce compliance by design. What I mean by that is if you try to integrate with, or if you try to manually change a resource that is living in your application, right, that is monitored by Kubernetes, and because Kubernetes is constantly monitoring the application as well as Kubernetes, like to be able to match the two things, what it's going to do if you have a component that is managed into a custom resource, if you change that component manually. So for example, if you add a role to a database, and that database role is managed by the custom resource, if you change it, if you change that component, Kubernetes will see, oh, wait, it doesn't match what I have in my custom resource. So it's going to revert it back. So the only way to change, interact with the custom resource, with what sits behind the real component that sits behind the custom resources, is to modify what is living in Kubernetes, the manifest that is living inside Kubernetes, right? So it's kind of forcing a bit of compliance, but what is running inside the cluster, not in terms of what you want to deploy in the cluster, is what is already there, right? But there are a couple of challenges. There's no standard for CRD because it's by design, it's 100% customized. So it means that create your own CRDs. There's no standard for it. So it depends on you in terms of how you want to implement this control. And ultimately, we're going to see with policy as code, you can do that. Challenges again, sprawl of custom resources, and also the supply chain quality control, because there are literally hundreds and hundreds of operators out there. On operatorhub.io, you can find some of them. You can find all of them if you just search on the web in Git repos. But the concern is really, how do you trust them? How do you guarantee that the whole supply chain of your software that is running in Kubernetes is secure? Well, that's up to you, right? But there are tool sets out there, but always check the source and check the code. Those things should be part of your daily concerns when you are deploying things into Kubernetes. Always double check what is there, check the code. There's nothing malicious there. It can happen, right? And another thing I've basically, I figured out is, well, documentation is hard to get when it comes to CRDs and operators. Don't get me wrong, there is documentation, but what I've noticed is your use case is always a little bit different that is not in the documentation. So you need to try out like different example and try to figure out, how to make it work. It's time consumable, but what we're going to build with DOKC, so data on Kubernetes, at least for the database operator, we're going to start working on a framework that will allow people to go on the DOKC community website, consume content there, where we'll have these operators can do this. This is the full schema. This is what you can configure. All this kind of more standardized way of defining what is available for database operators. So it should be there the next couple of months, hopefully. Okay, so now let's go into a little bit more details into how we can limit the blast radius and implement a bit more good practices in terms of security. So GitOps is the first one where it's really about having a pipeline, like a standard continuous integration pipeline, but the moment where your manifests are ready to get deployed into Kubernetes, you are using the same operator model, right? Instead of doing kubectl apply with your user, the principle is to say in GitOps, there are two mandatory things. One, you use your application code and manifests. You store them into Git repo so that any updates, any imperative action, rather than being done directly in the cluster, is done by a CI, by some automation tool, validated by people. You can do a PR or anything, then you will have some sort of automation CI portion that is going to generate all those new images, that is generate with customize or hand chart or whatever, is going to generate new manifest into a repo. And then you're going to have like a bit an operator and a solution, like can be like GitOps solution like Flux, or you can have Argo and a couple of others probably, but their job is to watch this repo where you have all the Kubernetes manifests. And when you have a change on those repository, is going to take those manifests into account, and the operator is going to acknowledge the new manifest and deploy it into Kubernetes. So there's no interaction between users and Kubernetes. That's one. So you don't have any permission or access issue to the cluster. So you have better control in terms of the attack surface of the cluster. And also second, which is inherently a benefit of Git, you have a version control system when you can track not only the application code, but also all your manifest, how you deploy the application. And as part of the GitOps pipeline, you can also have tools that is going to check compliance based on syntactic, it's always difficult for me to pronounce this, syntactic checks. I'm sorry for that. And Kyverno, OPA Gatekeeper, or OPA Gatekeeper are two examples. I'm going to show you this in a minute. But yeah, if you combine policy as code, which basically is going to check those manifests, compare them to your compliance rule, to your best practices, and it's going to tell Kubernetes, or the operator is going to tell Kubernetes, no, I'm not going to install this set of manifest because it's not compliant with our recommendation. Right? This is basically doing this. And the goal of that is also to decouple the validation of the policies from the enforcement. So the validation of the policies, the policy themselves can be represented as YAML inside Kubernetes, right? Because Kubernetes already has YAML, which is the perfect language to represent policies. So it's like eating your own dog food. You can have your policy engine self-hosted in Kubernetes, declarative format using YAML. So it can be, again, I prefer when it comes to Kubernetes, if it's Kube-Native, it's always better because it's just YAML, right? I mean, YAML, it is what it is, but at least you know all the in and outs. Obviously, it helps you control and validate the source of your application before committing to the cluster. So whether it's validation, but also mutation. So you can say, no, you're not complying. I'm not going to deploy what you want in Kubernetes. Or you can say, yeah, this is not conformant. I don't care anyway, because for everything that is being thrown to me, I need to add this bit, this bit, this bit, so that you are conformant, like changing the configuration before it reaches Kubernetes. This is called what we call mutation. Webhook mutation inside Kubernetes, where you can change the resources before they are deployed into the cluster. So I'll mention a couple of policy as code tools there. There are many other, OPA Gatekeeper, Kyverno, Datry, and others. But today we're going to be focusing on Kyverno. And the way it works is similar to every solution. So on the top here, this is the workflow to hook in your admission controller. So there are two hooks where you can influence things. As I said earlier, like you can mutate and apply changes to your resources before they get applied, which is mutating webhook admission, or validation admission, which is just about validating, and if it's not compliant, then that's it. It doesn't reach the cluster. So Kyverno implements some webhook, has its own controller for generating objects in case you need to mutate, or directly the policy controller in case you need to just validate some resources. It's quite nice, actually, but we're going to go into some of the features, but it's really important in terms of on that. So on that, if you don't know, because I didn't mention what we do. So on that, because I've been talking about stateful application, we are focused on stateful application and bring persistent storage to the stateful application with a plethora of enterprise-grade enterprise-grade feature. So, and everything we do is Kube-Native. So all of our features, you can control them using just labels and things like that. So having a policy as code component allows you to control how you want to deploy your storage component, which is critical when it comes to databases and more stateful applications. So this is how we play with policy as code. And it's great because they have a CLI that we're going to explore. We have, it can generate report. It can directly apply those check on running Kubernetes cluster, and it's super easy to use. And if you've been using OPA in the past, which has its own Rego kind of policy language, it can be difficult, or very difficult, should I say, to do policies with Rego. The good thing is, if it's super complex, if you have a super complex policy, yeah, you can do it with Rego. But with Kyverno, you can do you can already create a lot of policies. It's a bit more limited, but still, you can, at least for what I had to do, didn't have any problem. Actually, I was surprised on how simple that was, and can achieve already great things. Okay, so now let's go into the demo. So what we are going to build is an application that is sitting there. So I can maybe zoom on it. So it's a two-tier application. We have our front end, which is going to display randomly Marvel character cards on the screen, just using a Flask front-end application, and from the Marvel public API. But it's not directly requesting the Marvel APIs. On top of this, we have, when you deploy the application, you have a job that is running that is going to do request on those Marvel APIs and store like probably 700 or 800 different characters into a MongoDB cluster. And the application is just displaying a view of what the data set that is sitting within this MongoDB cluster. So effectively, the application is composed of a job that is populating the database, a front-end highly available deployment running Flask, and then we have a stateful set, which has a headless service. So headless service, if you're not aware, if you want to be able to address the individual pods of your stateful set by using their DNS name, you need to have a service, but you don't need cluster IP. This is why it's called a headless service. There's no load balancing. It doesn't, provision any cluster IP. It's just so that you can access the pods composing the stateful set by their DNS name. And this stateful set, as I said, is MongoDB. We are going to be using the MongoDB Operator to deploy the database. And you can also see that everything is controlled from a volume claim template to host the database. So what that means, it allows you for every database instance. So we have the primary node, secondary, and it should be, that's a typo. It should be third node. That's a secondary node, but it's a third node, primary and secondary node. And every one of them will have its dedicated persistent volume. So it's dedicated data store, and this is made possible because we specify a volume claim template on the stateful set. And again, it's not directly managed by the stateful set resource. The whole thing here, right, the whole database stateful set is managed by the, in our case, it's the community Kubernetes operator for MongoDB, right? So that's basically the application. And what we're going to do is deploy that application and playing with things, playing with resources we can change and see what our Kyverno policy is going to say and how you can use this sort of pipeline. So I'm going to be showing you Scaffold. I don't know if you're aware of that tool, but if you are a developer or just a DevOps excited person like me, Scaffold allows you to automate everything you need on your laptop from if from Docker build doesn't necessarily have to be Docker. So you build your image. It can build your image as you modify your code automatically. It can deploy where you want it to be deployed, any Kubernetes cluster, and you can specify also how you want to deploy it. You can run. You can have a continuous loop before, like just saving code on your file will trigger a new deployment, a new build of your image and deployment into your test cluster. So it does all these little automation that are very annoying to do manually when you're working on an app or constantly building Docker, Docker build, Kubernetes apply, or if you want to use customize to create your specific manifest for your environments. Scaffold is a single point of contact, should I say, to do all of that. It can use customize to deploy. It can use Docker to build. It can use Helm. It's compatible with many different tools. And also, when you do Scaffold run, at some point, it's going to deploy things in Kubernetes. And so Kyverno should be able to tell us, okay, no, I'm not going to let you deploy that MongoDB cluster or that deployment, etc. That's one way to use it. And the second way we're going to be using it is by using the CLI. So okay, I've got this manifest ready to get deployed. This is my policy manifest. Can you check the policy against the manifest and tell me the result? Rather than in the first case here, when you use Scaffold to deploy, then the policies are already running in the cluster. In the CLI tool, you can tell the tool, check those policies, but they are not in the cluster already. It's just policies are manifest and the application are manifest too. Okay, I see there are some, just checking on the question. Where can we see all this YAML file he's talking about? You mean, I don't get that question. You mean for this talk or like just manifest in Kubernetes? Yeah, I'm not sure I understand this one. Slides, yeah, slides will be downloadable. Okay, so before going there, let me unshare my screen. I'm gonna go through the development environment. So first, before going forward, let me show you just like prove the application should be working. So I'm gonna quickly reshare the slides there. Okay. So let me just run the command to forward the application. Okay, should be running now. Let's try it. So what we should see if the application is working is that view, right? So it's just some random character which are being loading from the database and should be able to refresh. Yeah, it's working fine. So let's share. Here you go. So on the screen right now, so I'm going to stop the application here. Here you go. Okay, so I've got some different folders that are displayed there. I've got my manifest. So when the question was asked, where are those manifests? They are here. Those are all the manifests I'll be using to deploy that are required to build this application. And typically how you generate those manifests, it's nothing. It's just Kubernetes native object, right? So you use kubectl dry run to start with a non-empty YAML file, and then you just fill the gaps, right? So as I said earlier, we have one job. So the component of that job is just running an image, and it's just going to directly, the code will just going to check the Marvel APIs, request all the characters, information, and insert it into MongoDB. Then we have the front end. So again, the front end is just basically running an image, right? So with this Flask application, we define the service of our application that is running on port 8080 on top of, and putting a cluster IP on top of the, the different pods. We have our storage class, because remember, we are running a stateful application, which means that the storage is going to be provisioned by on that, of course, in our case. So you need a manifest to create the storage class. So as I said earlier, the feature that we enable, we're going to change those manifests with customize, right? So, but the foundation are there. Here, basically, we don't enable any feature. We just specify XFS for the file system, as opposed to, X4 or other file system. This is the recommended one for MongoDB. And then we have our main component, which is the MongoDB Operator. This is how you can influence the MongoDB database configuration and deployment. So you can see, you can specify the number of members, the version, the type, the authentication, the users. And remember the stateful set, I told you, I'm not going to create a stateful set manifest because it's managed by the operator. So you can see the template for the stateful sets. So here you can see I'm going to be using storage class named default and sized 1 gig. But obviously, as you deploy your application, you can have different environment. You don't want to be deploying those base manifest in your production, and then in your dev environment, you will have like various parameters. So the first thing to do is to use customize to create your target manifest for the target environment. So I've got 2 of them here. So I'll show you the base manifest. So now I've got my dev overlay and the prod overlay. In this overlay, essentially, I'm just specifying the new configuration for the specific environment. So what is the difference for a job when it's in dev? So if it's in dev, then I'm going to give you this password to connect to the MongoDB. If it's a deployment, then if it's in dev, I want 2 replica. And I'm also giving you the password to connect to the MongoDB. Now for the MongoDB operator, all the configuration in dev, so if it's admin, then you want to add those particular permission. That's a CR custom resource. If later on, I'm trying to manually modify those, that won't work. You need to modify into the custom resource. And then, again, if it's in test, I want to be using the on that replicated storage class. I want a read-write once type of volume, and it needs to be 1 gig. And now, in terms of the on that features, I also want to enable replication. But let's say it's test, so I just want 1 replicas. But still, I need to do some performance testing, so I need to see how it behaves if you have encryption enabled, right? So those are the things I'm going to patch my base configuration with those elements. So the simple thing you can do then, if you want to see the end manifest depending on your environment, you just run customize, then build, then you select. Okay, I'm not in the right folder here. App manifests. I'm here, right? So I'm just going to run customize, right? Build, then overlay, dev. I'm not going to pipe it to Kyverno for the moment, but then there is 2 options. If you do it this way, so you've got it. So it's just outputting the end configuration, or you can also redirect to a file here. And now it's going to give you, this is the manifest that are going to be populated into the cluster. So you will find the patched manifests that are all there. And the next phase is to run kubectl apply to do that and deploy those manifests into the cluster. But as I said, if you're using Scaffold, then you can just specify a Scaffold configuration file. And here you're going to see the image it needs to build, the build command. And here I'm going to just tell him, okay, if you're using Scaffold, this is the path where you can find my dev overlay. So it's going to build the image, it's going to build the customized overlay and manifest. So, and then it's going to deploy it into Kubernetes directly, right? But now let's take a look at our policies. So our policies will be managed by Kyverno. So the things you can do with Kyverno, for example, let's say, so I've got 4 use cases here. Let's start with simple one here. So again, look at this. This is pure YAML. There's no specific language that is introduced. So what this does is going to check that the PVC size must be less or equal than 10 gig. I specify the resource, the path to the resource that I need to check, and the object. So I'm going to check, so here, kind MongoDB. So that means that I can not only control Kubernetes object, but also custom objects, such as custom resources, right? MongoDB community is not a Kubernetes native object. I've installed the operator, and now I've got access to that object. So I'm going through the path of the full path of that object until I reach volume claim template, resources, request, storage. I want it to be inferior or equal to 10 gig. And what amazed me, really, is that I tried it out this way. I was like, yeah, it's not going to work because it's a string. No, actually, it works this way. And I'm going to prove it to you. But, and that's it. There's no new language, no programming or anything, right? Same thing with replicas. So now I want to act on my remember on that storage class, number of replicas must be greater or equal to 1 for dev, and maybe for prod, right? I've got the same one, but it's 3, right? So it can work also on the storage class. Require encryption. That's an easy one as well. So you create the policy, give it a name, and now again I'm gonna focus on this particular line. StorageOS.com encryption true must be set into your manifest. Same thing with MongoDB permission. So again, working on the Mongo custom resource, you can have like a bit advanced syntax saying like at least one of those must be present in the manifest, right? So you can kind of extend the base language to put some logic. And there's variables. I invite you to go through the documentation, but it's really, really nice to implement policy as code. So now, hopefully you understand all that. So where can we see all these YAML files is talking about? I will give you the link in the slides. I will add a slide with a link to the repo. Everything is on GitHub. So hopefully you can also play with this. Okay, so now let's try first. So the policy there, again, they are just being applied into Kubernetes. It's a custom resource itself. So remember, I told you it's kind of eating your own dog food. If I do a Kubernetes get CLDs, you will see that I have policies.kyverno.io. You will have the cluster policies, and to the same extent, I have MongoDB, custom resources. So all of these are now Kubernetes objects. This is just what it means. So now if I can do Kubernetes get cluster policy first, cluster policy. I can see that I've got all those already implemented in the cluster, and this is just a representation as an object of the manifest I've just showed you. So if I do this, for example, if I export it, if I output it into YAML, you will see it's the exact same content as what is inside the YAML file, right? Okay, so the first thing to do, the policies are living in the cluster, which means that if I try to deploy my application into the cluster manually, if one of the manifest is not compliant, it should be rejected. So for that, let me first delete the application. So remember, I'm using Scaffold. So Scaffold, again, is going to help me. Just doing Scaffold delete. It's going to delete my, all my, the component of my application. I should probably also no, that's fine. So you can see all the components have been deleted. Now let's try to change something, right? So we are in dev. Let's try to, let's say, so I'm going to go into my manifest, right? Back into my manifest. I want to change maybe, let's say, false for encryption, right? So now, if I do this and Scaffold run, it's a bit slow to respond. So you're going to see it's going to start building the image, doing everything, but hopefully at some point, yeah, you can see when it's trying. So what it's doing here, Scaffold start the build process of the image. You see that I didn't do any change to my application. So it's taking already the image I have in cache, and then it's going to deploy it with Customize in the dev environment. But guess what? Now it's going to tell you admission webhook Kyverno fail. What is wrong? Well, validation error on that encryption must be enabled. Rule check for encryption failed. So that's good, right? This is how we implement policy as code. So, but in the meantime, it's still started to deploy the application. Some components are missing there, but it started. You see, 42 seconds. It started to deploy the application. Which ultimately you want to avoid. This is why you need to have some sort of CI. It's going to tell you, okay, this is my manifest for my application. This is my manifest for my policy. Can you tell me the result to begin with? Okay. So let me first delete this application. Now we're going to be using the CLI. So for this, what I can do is, so I've built a little script, but I'm going to do first is customize this. So you can, what I've done before, right? Remember how you generate manifest with customize. Customize build. So I don't want prod, I want dev, right? So I want dev. So the path is going to be dev to find all the manifest and the patches. Then I can pipe this to Kyverno, the Kyverno CLI, and it's going to tell me in the dev resources, which are those ones here, right? The dev policies. So it's going to check not in the cluster policies, but it's going to check this directory for all the policies that are there. And that's the difference. So now, okay, overlay, sorry, it's not the right one. You know what? I prefer to run the script. So the script is there. Oh, sorry. Yeah, I was not in the right directory. I'm sorry for this. Come on. Okay. Here we go. So this is the script. So it's basically doing the same thing again. And this one should work too now. So you can see there is one fail, which is the same thing. It's about the encryption, right? Except this time, I didn't apply the manifest into Kubernetes. So before my manifest is applied into Kubernetes, I know the answer, right? So if I change it back to true on my manifest now, then I shouldn't be seeing. I've got fail 0, right? So what you can do now is, so I've just built like a quick script, CI validates. You just put this into a script because ultimately what you want to see is either passed or failed, and depending on this, then you will trigger the rest of the pipeline or not. So if I do dev, should be a pass now, and prod, I don't have any, should be fine too, right? So this one on prod, so because in prod I've put some errors there, so you can see just in my prod manifest, I've got some components that are not compliant, and then you can rerun the command to just display, what has been wrong, what manifests are not compliant. Okay, so that was it for the demo. Let me unshare it and come back to the slides. Okay, so this is what we have built and what I've been showing you as a quick summary. Here you go. So hopefully it was useful. Hopefully you also had fun. I had fun showing you all that. I'm passionate about all this stuff, and hopefully I can also share this passion with you. Key takeaways for today. We've shown that DevOps at scale inherits the same risk as automation at scale, what you need to address. At the same time, we have a sprawl of resources in Kubernetes because everyone now is using Kubernetes operators, which is automating Kubernetes automation even more. So basically giving you a lot of resources in Kubernetes. And how do we control this? Should we put guardrail in place? Yeah, to a certain extent, as long, in my opinion, and this is just my opinion as Nick, as long as it's Kube-native, it should not hinder your developers or the innovation you can bring to the business. So pick the right tools, adopt GitOps because it helps you reduce manual interaction with the cluster, reduce the attack surface, and also increase security, improve compliance. Finally, work on policy as code. I give you an example today with Kyverno because it allows you to enforce best practices, compliance rules before actually workloads are deployed in the cluster and at every stage of the application lifecycle. Call to action now. Last slide for you today. If I can ask you something, would be this. Check us out on online try our self-paced lab on Instruct, where you can play with on that features more in details. You can test our solution in a self-evaluation manner. If you want to test your stateful application databases, please feel free. We have just launched our portal if you want to get more visibility into your cluster around storage and stateful application. You can sign it up here. Again, it's free to begin with. Subscribe to the newsletter on the website, on that.io at the bottom. You can insert your email. You can also reach out to me on Slack if you want to have more information about the demo I did today, or just have other questions about different things. And last but not least, we are also recruiting. Check out our position on that.io/company. Even if your ideal job is not there, you can still reach out to us on Slack because we are constantly hiring top talent. So again, thank you for joining today. Hopefully it was useful. I was really thrilled to share all this insight with you, and see you in the next one.